Hello everyone, here are the answers to yesterday's AP practice problems. I wanted to go over these first. So go ahead and get yours out and see how you did with these. Feel free at any time to pause a video, especially if you need to write some things down with these problems if you weren't quite sure how to start them. Make sure you copy them down as I go over them. So let's take a look at this first one. Now on this first one we were allowed to use a calculator. And if you weren't quite sure what that last term said, it was x to the fourth plus 2x squared. So now that you know that, if you need to work on it, go ahead and pause the video, try it on your own, give yourself a couple minutes, and then resume playing. But here we're asked, which of the following is an equation of the line tangent to the graph of f of x at the point where f prime of x is equal to 1? So this information right here is giving us the slope of the tangent line, telling us that it is equal to 1. So what we need to start looking at here is the first derivative. So we want f prime of x is going to equal 4x cubed plus 4x. Now, kind of going back to this, the slope of the tangent line has to be 1, and these are the equations of the tangent line. So right away, we could rule out a, because look at that slope. We don't want that. We need our slope to be 1. The rest of these slopes are 1. So now what we're going to do is set this, if this is the slope of the tangent line, we will need to set it equal to 1. Now we would try to solve by factoring, and that's not going to happen if we bring everything over to one side, set it equal to 0. So go to your calculator. This is where we need to use it. Go to a calculator page, and we want to go to menu 3, 1. So it's going to bring up the solve. This is the solve feature. We only use this if we absolutely can't solve by factoring. You just want to type in the entire equation. 1 equals 4x cubed plus 4x, but you have to tell the calculator what to solve for. So after that, we need comma x. It's telling the calculator to solve for x. When you do, just round it to about 3 decimal places. So x is approximately, you should be getting a 0.237. Okay, so we have a couple good pieces of information. We have the slope of our tangent line. We have the x value of our point. We just need the y value. What are we going to do to find that? We're going to substitute the 0.237 back into f of x. So we want to figure out f of 0.237. Just use your calculator for this. Again, round it to 3 decimal places. And we should be getting a 0.115. All right, so we have our point. We now have 0.237, 0.115. The slope of our tangent line is 1. We can write our equation. If you do notice, all of these are in slope-intercept form. But we could still start with point-slope form. We could say y minus 0.115 equals 1 times x minus 0.237. Solve for y, we just get x minus 0.237 plus 0.115, and then this turns into y equals x minus 0.122. And that was D. Okay, let's take a look at this next one. You notice here we're given a graph. This is the velocity of this bug at time t. So this is a velocity time graph. Our question here, let's go to this first. At what value of t does the bug change direction? So we know a particle or an object is going to change direction when velocity changes signs. Meaning it changes either from positive to negative or from negative to positive. So velocity is at 0 here, is 0 at 0, but that's not helping us because that's where we're starting and it's not changing from positive to negative. So the only other place it is right here, and there's our answer. So here we just needed our ability to understand a velocity time graph. All right, this next one I already have worked out. Just want to go through the steps. It's a lot more basic than the first example or the first problem was. This is something that we have practiced before, and we're going to continue to practice because it's a favorite on the AP exam. Here's f of x. We want to know which of the following is an equation of the line tangent to the graph of f at the point where x equals -1. So we start right here, find f prime of x, then we find f prime at -1. Turns out that that's 7, so the slope of our tangent line is 7. Next, we have the x value. We need to find the y value, which turns out to be 4, so we need to calculate f of -1, which gives us 4. And then I use point slope form again to write the equation, and then that turns out to be cy equals 7x plus 11. But feel free to pause this video, look over the steps again, compare them to what you did. If you've got a different answer, see where you might have made a mistake. And if you still have questions, just ask me on Monday. Okay, let's take a look at our last one. Another particle problem. Here we're given x of t for the position function. We want to know at what time t is a particle at rest. Well, that's when our velocity is equal to 0. What's important here is to understand that relationship there, that we just have to take the first derivative of the position function. And then we want to set it equal to 0 and solve. So we do so by factoring out a 6 and then factoring the trinomial that's left. And that's how we get the t is equal to 3 and 4. All right, so you guys also had to find the derivatives of the last two trig functions. So what I want you to do now is get out a clean sheet of paper. You're going to keep all 6 derivatives in one spot and have nothing else on the paper for right now. We'll add to it later. So I want you to copy this down exactly how I have this. Notice everything I have in blue over there, that's there for a reason. So I want derivative of cosine, cotangent, and cosecant to be on the right side. Derivatives of sine, tangent, and secant to be over on the left side. So copy this down. And then we're going to try to notice some similarities, some differences between these as ways to help us remember them a lot better, because we do need to know these by heart eventually. Okay, so pause the video if you need time to write these down. So if you notice everything I have over here on the right in blue, all of those trig functions start with a c, cosine, cotangent, cosecant. Look at all their derivatives. They're negative. So any derivative of a trig function that starts with c is going to be negative. The other 3 obviously here are positive. But then let's kind of take a look why I have them written next to each other horizontally here. Derivative of sine is cosine, so sine and cosine are connected and vice versa. It's just that the derivative of cosine is negative. Derivative of tangent turns out to be secant square x, and this is similar. Derivative of cotangent involves a cosecant square x, but it's negative. So secant square x and negative cosecant square x are those derivatives there. The last two, notice how they're 2 parts. There's 2 trig functions for their derivatives. So derivative of secant is, and we could write this as secant x tangent x or tangent x secant x. That order doesn't matter. But then derivative of cosecant is a negative cotangent cosecant or negative cosecant cotangent. Either way, it has the original function in it. So derivative of secant x has the secant x times a tangent x. Derivative of cosecant has cosecant in it. Then it's still times a negative cotangent. So you need to start looking these over, rewriting them. Practice writing them without looking at them. Write them repeatedly, and they'll stay with you a lot better. All right, so let's practice 2 problems. These are our only 2 new examples for today. So it's a combination of the rules here. So go ahead and pause this to give this a try, but hopefully this is why I have this written off to the side. We have to use the product rule. And if you need to look back at your list, because we just wrote it out now, make sure you do that. But give this a try. Let's see what you come up with. All right, so let's see how you did. So I'm going to call x cubed my u secant xv. So we need uv prime. So that's going to be x cubed We just said the derivative of secant x. Remember, one way to remember this is it's going to have secant x in it. It's positive. It was one of the ones on the left side. It's going to have secant x in it. It also has tangent x. So there's my uv prime. Plus v, which is secant x. U prime is 3x squared. Now technically, this is really it. We could just make it look a little bit nicer. First part's just going to stay the same. And then the second part, we just write that 3x squared first. So this is acceptable. But just in case, as a multiple choice, it might have had something that looked a little different. They may just factor out a common factor, GCF here, of x squared secant x. And then this would just leave us with x tangent x, and then plus 3. So that's another way to look at this. Now, if you check this on your calculator puts everything in terms of sine and cosine. So I wouldn't worry about doing that here because it's going to look way more complicated and a lot more steps to try to get this to turn into what your calculator shows. So either one of these two is perfectly fine. All right, take your time to copy this down. See what you come up with on your own. Pause the video while you work on this. So if you notice, we definitely need the quotient rule. So we're going to start f prime at theta. Theta is just another variable like x or t. So we're going to have low, which is tangent theta, d high, so here's the derivative of secant again, so that's going to become secant theta tangent theta. And then the derivative of 1 is just 0, so I really didn't even need the parentheses here. So I have my low d high minus my high, I do need parentheses here, d low, so the derivative of tangent theta is secant square theta, all over low, low, so tangent square theta. Technically, this is it, but we could see where it kind of leads us, see if it simplifies into something a little bit nicer. So I'm going to go ahead and multiply. We'll have secant theta times tangent square theta. I'll distribute the secant square theta, so we'll get minus secant cubed theta minus secant square theta all over tangent square theta. So this is acceptable. But let's kind of take this a little further. Let's go ahead and factor out a secant theta from every term. We would be left with tangent square theta minus secant square theta minus secant theta over tangent square theta. So sometimes we just try this to see if it could turn into something a little bit nicer. But on a test or a quiz, this step right here is perfectly fine. If you notice this in here, that looks like some pieces of a Pythagorean identity. If you recall, tangent square theta plus 1 is equal to secant square theta. So if I rearrange this a little bit and say tangent square theta minus secant square theta is equal to a negative 1, if I just switch those last two terms, so I could replace this now. So I'm going to get a negative 1 minus secant theta. Now the reason we do this is because in some future problems, we're going to have to use this again, and we want it to be in the nicest form possible. We don't want it, all this stuff if we have to maybe take the derivative again or have to substitute this in. So that looks a little bit better, so that's acceptable. Let's go a little bit further. What I'm going to do is actually look at the tangent square theta. Over here, if I solve this for tangent square theta, we could say it's secant square theta minus 1. So let's take a look at where this leads us to. So we have secant theta and then negative 1 minus secant theta over secant square theta minus 1. I'm actually going to factor out a negative 1 from up here. I'll put it out in front. So we'll have a negative secant theta. Then this leaves us with a 1 plus secant theta. Now this denominator is actually a difference of squares. We could say it's secant theta minus 1 and then secant theta plus 1. And now we can simplify even further. Secant theta plus 1s divide out, and we're left with negative secant theta over secant theta minus 1. And there we go. So we have 3 correct versions. It all depends on how we need to use it as to how far we take it. So this first one is perfectly fine if I'm just asking you to find the first derivative. The second part, leading really into this third part, if we were going to do anything with it, we wanted to keep going. So then this final part is probably the easiest version. You can definitely tell it looks a lot nicer, a lot cleaner than our very first answer. All right, so practice the 6 trig derivative formulas. On page 133, now take a look at 36, but continue at 31. Page 139, do the quick review. And page 140, try these 4 problems. But for Monday, please be ready with any questions that you have over what we did yesterday and anything in today's lesson as well. So take care, guys. Have a good weekend. Happy Halloween.